Hey everyone, welcome back to another math lesson. Today we are going to be moving on to lesson 4, developing and applying the quadratic formula. Okay, so let's get started. We can use this formula to solve quadratic equations of the form ax squared plus bx plus c is equal to 0 that cannot be factored. So here is our formula. X is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. This formula can even be used if the equation can be solved by factoring or using square roots. So even if it can't be factored, you can still use this formula to factor, okay, or finding or using these square roots, okay? Example 1. Solve using the quadratic formula. X squared minus 6x plus 5. Okay, so again, it's just nice for us to label a is 1, b is negative 6. Yes, the negative is attached to the 6, so you bring it with you, okay, and c is 5. Okay, so that means, and let's write down the formula, x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's substitute all the values in, a being 1, b being negative 6, and c being 5. So now we have x is equal to negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 5 all over 2 times 1. Okay, so let's start chipping away at some of these operations here. So x is equal to, well, this is 6 plus or minus the square root of negative 6 squared is 36 minus, okay, that's 4 times 1 times 5. Well, negative 4 times 5 is going to be negative 20. This is all over 2. Okay, ran out of room, so I'm going to come up here. So we have x is equal to 6 plus minus the root of, well, 36 minus 20 is 16 all over 2. The square root of 16 is 4, so that we have x is equal to 6 plus or minus 4 all over 2. We can divide everything by 2 to say that x is equal to 3 plus or minus 2. So that means that x is equal to either 5 or 1. That is using the quadratic formula. Moving on to b, we have x squared plus 6x minus 7 is equal to 0. So again, a is 1, b is 6, c is negative 7. So using the quadratic formula, x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, so that we have x is equal to, well, this is going to be negative 6 plus minus the square root of 6 squared minus 4 times 1 times negative 7 all over 2 times 1. Okay, so it's going to be x is equal to negative 6 plus minus. So now we're going to figure out all the operations that's inside the square root there. The root of 36 minus, well, okay, so it's going to be negative 4 times 1, so it's still negative 4. So we have negative 4 times negative 7, which is actually going to be positive 28. All over 2. So 36 plus 28, that should give us 64. So now we have x is equal to negative 6 plus or minus the root of 64 all over 2. But we know the square root is 64. That's 8. Okay, so I'm just going to bring this up here. So we have x is equal to negative 6 plus or minus 8 all over 2. Divide everything by 2. We have x is equal to negative 3 plus or minus 4, which means that x is equal to either 1 or x is equal to negative 7. C, we have 3x squared minus 5x plus 7. So we have a is equal to 3, b is equal to negative 5, and c is equal to 7. Okay, so this is going to be x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Again, it's best if you write out the formula each time. That way you get accustomed to using it and you get used to writing it down and it becomes muscle memory and all that stuff. Okay, so this is going to be now x is equal to, as we fill everything in, negative 5 plus or minus the root of negative 5 squared minus 4 times 3 times 7. And it's all over 2 times 3. So we have x is equal to 5 plus or minus the root of, well, negative 5 squared is 25. 4 times 3 is 12. 12 times 7, that should be 84. So that's going to be minus 84 all over 6. So far, so good. Let's do the last operation inside the square root. So we have x is equal to 5 plus or minus the root of 25 minus 84. That should be negative 59. That's all over 6. Now, can you take a square root of a negative number? No. So if you have a negative under the square root, there is no solution. So you won't have any roots, any zeros, okay? No x-intercepts, okay? So that means there will be no solution. Okay? So you cannot have, so let's just make a little note for ourselves. Cannot square root a negative number. So there's no solution to this problem. Example 2 is a review of simplifying radicals. Okay, so we're going to simplify the following. We have x is equal to 50 plus or minus the root of 50 over 10. So let's split apart the square root of 50. Okay, so we have x is equal to 5 plus or minus the root of, well, that's 25 times 2. All over 10. Okay, so we can now split that up. We can now take the root of 25 out from underneath the root, because it is a perfect square. So we have 5 plus or minus 5 roots of 2 all over 10. And what we can do now is we have something common. Okay, 5 is common. So we're going to divide each thing. So we're going to divide everything by 5. Leave the root 2 alone. Okay, the 5 out in front of it, that's telling you that there are 5 of those roots of 2. So we're going to divide everything by 5. So if we divide everything by 5, we should get 1 plus or minus the root of 2 all over 2. Okay, that's as simplified as we can go without actually answering it, without giving an actual decimal number. So there you go. That's the final answer there. Moving on to B. 8 plus or minus the root of 24 over 4. So we're going to do the same thing. We're going to split up 24 so that we have something in a square. We have a perfect square. So that's going to be x is equal to 8 plus or minus the root of 4 times 6. Okay. All over 4. The square root of 4 is 2. So we have x is equal to 8 plus or minus 2 roots of 6 all over 4. So now we're going to divide everything by 2 to simplify it. So we have x is equal to 4 plus or minus the root of 6 all over 2. You can't simplify it any further, okay, because there is no coefficient in front of the root of 6. I know what you're thinking. You're thinking, well, 6 is a positive number. Can I not divide it by 2? Okay. You can't because of the root. Okay. So you cannot divide the root by 2 anymore. It's done. So this is your final answer here. Example 3, we're going to solve using the quadratic formula. So what we're going to do is we are going to expand the brackets, move the 5 over because we need it to be equal to 0. So let's expand the brackets. We get 2x squared minus 2x plus x minus 1 is equal to 5x. Okay. I'm going to move the negative 5x over now because it corresponds with these two. We have 2x squared. So we have negative 2x plus x, that's negative x, minus 5 more, so we have negative 6x minus 1 is equal to 0. A is equal to 2, B is equal to negative 6, and C is equal to negative 1. So, quadratic formula, x is equal to negative b plus minus the root of b squared minus 4ac all over 2a. Substituting in, we get negative 6 plus minus the root of negative 6 squared minus 4 times 2 times negative 1. And this is all being divided by 2 times negative 1. I ran out of room, so I'm going to go up here. So we have x is equal to 6 plus or minus the root of 36. Here we have negative 4 times 2 is negative 8, multiplied by negative 1, which is 8, all over negative 2. So this is going to be x is equal to 6 plus or minus the root of 36 plus 8 gives us 44 all over negative 2. We can simplify this radical, so let's do that. So we have x is equal to 6 plus or minus the root. So we have 4 times 11 all over negative 2. X is equal to 6 plus or minus. We have 2 roots of 11 all being divided by negative 2. Okay, we can divide everything. Okay, we can divide everything by negative 2. So at which point we get x is equal to negative 6 plus or minus the root of 11. Oh, sorry, not 6. Sorry, it should be negative 3. There's our final answer.
Hey people, so I realized when I was editing the video, I actually made a mistake. So we're going to go ahead, we're going to go back and fix the mistake where I said it was 2 times negative 1 for the a value, but in fact a is actually 2. I'm just going to make all my corrections in red. Okay, so it's 2 times 2 in the bottom, which means this is going to be 4. So everything is the same in your numerator. Okay, nothing's changed for your numerator, but now when we simplify, the final answer should be 3 plus or minus 11 over 2. Okay, so that should be your final answer for this problem.
Moving on to our final example, we have 1/2 x squared plus 5 over 4x is equal to 3. So what we want to do is let's get rid of all the fractions. Okay, so let's multiply everything by 4. Okay, so let's multiply everything by 4. Why? As it gets rid of the 4 in the denominator. The 5 over 4 gets rid of that 4. Okay, so we're going to multiply everything by 4. Okay. So half of 4 is 2. We have 2x squared plus 5x is equal to 12. Move the 12 over. We have 2x squared plus 5x minus 12 is equal to 0. Solving with the quadratic formula, a is 2, b is 5, and c is negative 12. Okay, using the quadratic formula, it should be written out like this. Okay, so now we substitute in. We get x is equal to negative 5 plus minus the root of 5 squared minus 4 times 2 times negative 12. Oh, writing sideways here. All over 2 times 2. Okay. Simplifying it, we now have x is equal to negative 5 plus or minus the root of 25. 4 times 2 is negative 8. Negative 8 times negative 12 should give us positive 96. Okay, and that's all being divided by 4. Okay, so now we have x is equal to negative 5 plus or minus the root of, okay, this is 25 plus 96. That should be 121. all over 4. Well, the root of 121 is 11, so we have x is equal to negative 5 plus or minus 11 over 4. So that means that x equals, okay, so we have negative 5 plus 11 is 6 over 4, which is 3 over 2. And x is equal to negative 5 minus 11 is negative 16, divided by 4 is negative 4. So there you go. 2 answers. Note, the quadratic formula is probably the best method to use when solving word problems, since often the numbers can be decimals, fractions, or can be very large numbers. Okay, so it's best to use the quadratic formula because it will give you an answer almost every time. Well, that is it for today's lesson using the quadratic formula. I hope you enjoyed it. Remember, when it comes to math, keep calm and show your work.